Do or do not. There is no try. Symmetry is what we talk about today. Okay, and that's about the extent of my Yoda. So, symmetry, last section of this unit. Basically, what's happening is when things are symmetric, um, thinking of it as it doesn't change. No, it's the same. And there's two different types of symmetry we're going to talk about. This is going to be a very brief set of notes, and then we're going to do more about it in class when I can actually show you a bunch of different pictures and different things like that. So hopefully this goes quickly. So there's two types: reflectional, and this is where you have lines of symmetry. And what we're thinking of is a mirror image across the line. Across the line. So, for example, we've got a triangle. So basically what we're looking for is where can we draw a line on this triangle where if you folded it over, it would match perfectly, or that the mirror image is 100% correct. And on this one, it would be right down the middle. So if we folded that directly over the middle, right? Boom, 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 boom. It should match perfectly. Which it does. See? Bloop and bloop. So, that's all a line of symmetry is, and that's reflectional symmetry, meaning that it reflects across. So a bunch of different shapes have different types, have different lines of symmetry. Like one of the ones that a lot of people will make one small mistake on is a rectangle, actually. So, and the reason for that is two of them are really easy. You know, horizontal and vertical. The one that people make a mistake on is sometimes they'll think you can do this diagonally as well, and that is not true. If you have a rectangle, right? I've kind of made myself a little rectangle here, and you try to fold it diagonally, it doesn't match up on itself. So that's what happens when you fold a rectangle diagonally. It ends up not matching itself. See, there's extras. So you can't have a diagonal line of symmetry on a rectangle. That was a really long time of me just doing one rectangle and saying that one thing. So you're looking for a mirror image, and so the things to think about is if you fold it, will it match? Right. The other thing you can have is a rotational. That's where if you spin it a certain amount of degrees and it looks the same. Easiest one to think about there is usually just a square, right? We got a square, right? If you rotate it 90 degrees, it's still a square. 180 degrees, still a square. 270 degrees, still a square. And then 360 means you went back to this where you started, and we don't really care about that. So You're spinning it a certain amount of degrees to make it look the same. Like literally exactly the same, not standing on its head or something like that. So rectangle, that's 90 degrees. Bleh, it's not the same. But if you do 180 degrees, it looked exactly how it did when we started. So a rectangle, what you would say is it has rotational by 180 degrees. The one thing that you should know, okay, there's more than one thing you should know, but one other thing that you should know is that if it's a regular shape, which means all sides are congruent, you can do 360 divided by the number of sides, and that will equal its rotational symmetry. Rotational, man, my handwriting. So basically, if you had a perfect, right, equilateral triangle, if you do 360 divided by 3, that equals 120 degrees. So basically, you could rotate this by 120 degrees, which means 120 and 240. And if you do that, so that's basically 120 degree rotation right there, 240 degree rotation, and then 360 to go back to where it started. So with a regular shape where all sides are congruent, just do 360 divided by that number of sides, and that'll tell you how many degrees of rotational symmetry it has. Boom. Done.